Welcome to the second lesson of the chemical changes topic. In this topic, the key questions are 1. How do acids react with oxides? 2. What is a neutralization reaction? 3. What are salts? Key terms that you need to be familiar with: acids, neutralization, salts. In today's lesson, we will talk about the reactions of acids with oxides and neutralization reactions. Acids are chemicals that dissociate into hydrogen ions, H positive, and a negative ion. Acids can react with certain metals while they produce hydrogen. For example, when magnesium reacts with hydrochloric acid, it forms hydrogen and magnesium chloride. Another important type of acid reactions is their reactions with bases, alkalis. Task: now please pause the video and think about what acids and bases are. Hint: remember, the presence of an H atom was a requirement for a substance to be a base. Extension: how can you describe acid-base equilibria? Now let's discuss these together. The Bronsted-Lowry theory of acids and bases describes the acid-base equilibrium as a proton H-positive transfer. Acids are substances that can donate H-positive ions, while bases can accept H-positive ions. Therefore, when an acid is losing its H atom, it will become a base via the following equilibrium: HA, H plus A minus, where A minus is now a base. This means that acids and bases cannot be separated. Whenever an H positive is donated by an acid, that is picked up by a corresponding base. For example, aqueous hydrochloric acid, the HCl and H2O molecules are in the following equilibrium, where HCl is an acid and H2O is a base. Water can also act as a base. For example, in the case of NH3, where H2O acts as an acid as it is a proton donor. During neutralization, one of the products is always a salt. The salt's name is determined by the acid and the alkali it was formed from. Task: now please pause the video and think about what salt is formed when potassium hydroxide reacts with sulfuric acid. Hint: sulfuric acid contains sulfate ions. Extension: how can you describe the solubility of sulfates in water? Now let's discuss these together. Potassium hydroxide plus sulfuric acid goes to potassium sulfate plus water. The second term of the salt is determined by the acid's name and the first term's name by the alkali's name. Water is always a product of neutralization that is formed via the H plus OH negative to H2O reaction. Sulfates are often insoluble in water, apart from some alkali metal sulfates. Sodium and potassium sulfates are soluble, while group 2 sulfates are insoluble. Barium sulfate is not soluble almost at all and is used in radioactive medicine. Carbonate salts are also mainly insoluble.